is called the double-edged straight-edge conjecture. Are we recording? We're recording. Okay. Now we're recording. There we go. So double-edged straight-edge conjecture says that if two parallel lines are intersected by a second pair of parallel lines that are the same distance apart as the first part, then the parallelogram formed is a blank. Okay? And one way you can do that is by taking we're going to get a piece of paper. Okay? We're going to get my ruler over here. Tools. I have a ruler somewhere, right? Where's my ruler? Do you guys see a ruler? There it is. Okay? And here's my ruler, 20 cents, doesn't matter what I call it. A 1 meter ruler. There's my ruler. If you want a really good ruler, you could use Napoleon as your ruler. Okay? So here's a
that was funny to do there.
So you can take your ruler, and I'm going to try, I wonder if it will let me do this. Draw right along it. Let me do that. Okay? Oh, it did. Wow, look at that. So I'm going to use this as my straight edge. Watch this. Let's see if that works. Whoa. Is that cool? Okay. And now I'm going to take, and I'm going to draw along this edge, like that. Okay? Isn't that cool? And now I can take my ruler, and I'm going to turn it. Turn it. Let's turn it quite a bit. Doesn't matter how much you turn it. And now I'm going to do the same thing again. Okay? I'm going to trace here. And I'm going to trace here. Oh, that didn't work. I got to get it right next to the ruler. Right? So I'm going to try to go right next to the ruler there. Oh, thanks. I have to use a pen. Thank you. Go right. Don't use a straight edge. Use a pen. So I'm going to go like this. Whoops. No, I'm not. There we go. Look at that. Whoa. And I'm going to move away my ruler. I could even... What shape is this? It's a rhombus. Okay? And a rhombus, this, and this are all congruent. And that's what the double straight edge conjecture says. That if you, what does it say? It says if two parallel lines are intersected by a second pair of parallel lines the same distance apart, then the parallelogram formed is a rhombus. Okay? Now we're going to look at something about the diagonals of a parallelogram. That's the next conjecture. That's pretty easy. So I'm not of a rhombus. Okay? So I'm going to draw in the diagonals. What appears to be true about the diagonals of a rhombus? They bisect each other just like in a parallelogram, but there's something else that's more special than just in a parallelogram. Very good. You should be writing these down on your conjecture sheet, okay? Some of you guys, so where did I find that? This is C49. Okay? The diagonals of a rhombus are perpendicular. Okay? And like, who said bisect each other? Connor said, and they bisect each other, just like they do in a parallelogram. So since a rhombus is a parallelogram with 4 equal sides, the diagonals bisect each other, but more interestingly, they're at 90 degrees to each other. So you can construct a rhombus. Watch, this is kind of cool. If I were just to take one line and another line, let's pretend that I exactly bisect this line. Well, I'll do it with Geometry Sketchpad. Let me show you. Okay? Yeah, I'll do it. But if I were to take another line, and it doesn't matter what length I make that, but if those things connect at the midpoint, okay? So this is congruent to that, and that's congruent to that, and that's congruent to that, then when I connect the sides, okay? Boom, 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 boom. What shape should I get? A rhombus. Isn't that cool? Good. So if the diagonals are perpendicular and they bisect each other, then you have a rhombus. Conversely, if you have a rhombus, the diagonals bisect each other and they're perpendicular. Okay, so that's 49. Rhombus angles conjecture. The diagonals of a rhombus, you know that James got it already. Now this is not true for a parallelogram. In a rhombus, this angle is congruent to that angle. Okay? And this angle here is congruent to that angle. That is not true for a parallelogram. So C50, you should write that down. The diagonals of a rhombus bisect the angles of a rhombus. Questions? Easy enough? Okay? Because notice that that's not true for a plain old parallelogram. If I were to draw a plain old parallelogram, okay? Okay? Does it appear that the diagonals cut the angles in half? Is angle 1 here congruent to angle 2 here? Yes? No?
Yes.
No.
No.
No. No. But in a rhombus, those angles are congruent. Okay? Did you write that down? Write it down. Lizzie, did you write that down?
Yeah, I did.
Good. Okay. Two more quick conjectures. One, they have to do with rectangles. Okay? And I told you about the rectangle family. I didn't tell you about the family? The 90-degree angle family? They were driving down the street and they had a horrible car accident. And they became a bunch of rectangles. But then the ambulance came and he said, "Oh my gosh, is everyone okay?" They go, "Don't worry, we're all right." The 90 degrees. I made that one up. Okay. So that was pretty good, huh? Was that good? We're all right? Okay. So in a rectangle, we're just going to do one more thing. Let's get a rectangle here. Here's a rectangle. What? Shush. What do you think is true about the diagonals of a rectangle? Who wants to give me a conjecture? I'll give you a point. Tell me one thing about diagonals of a rectangle. Go ahead, Pravi.
Are they equal?
They are congruent. Okay. Diagonals of a rectangle are congruent. Okay, I'll give you a point in a minute. Right? This length is equal to that length. Then you can prove that pretty easily because you have right angles here, and it's a rectangle is a parallelogram. So side, angle, side, side, angle, side. Right? Those two overlapping triangles would be congruent. Therefore, the diagonals would have to be congruent as well. Who can tell me one more thing about the diagonals of a parallelogram? Elizabeth.
They bisect each other.
Perfect. Okay, and they bisect each other because a rectangle is a parallelogram. This piece is congruent to that piece, and that piece is congruent to that piece. Okay. Last thing is a square. Okay. Do you want to do a square? Did you ever what? Okay, Connor's gonna. Where's that last conjecture? See, square diagonals that are blank. Okay. Let's just do a square, and then we'll be kind of done with this. All right. So a square. Connor's gonna tell us in a minute. Where's a square? That's a square, right? Tell me some stuff about. You want to tell me all three things about the diagonals of the square?
Sure.
Go ahead, Connor.
They're perpendicular.
Very good.
They bisect each other.
Yep.
And they are congruent.
Very good. Because a square is both a parallelogram and a rhombus and a rectangle, right? It's all four of those things. Therefore, all the properties of a rhombus and a parallelogram and a rectangle are going to be true. So they're perpendicular, they bisect each other, and they're congruent. And that's all you got to know for tonight's one. Okay? So you can start on that. For those of you out in TV land watching this cutting edge video and listening to my really good jokes, we are doing page 294, 1 through 13, which are all, I think 1 through 13 are just true, false, or matching or something. 1 through 12, aren't they?
1 through 10.
1 through 10 are just, what are they matching? Matching. 1 through 10 are matching, so that's 14, so it's not that much, right? 14 through 24 even. And then I didn't feel like that was enough, so I gave you 28, which is one of those find all the angles. Right? All right. And remember, you heard it here on Mr. Leader's Cutting Edge YouTube channel. Say goodbye, class.
Goodbye.
Bye.